Hi there, welcome to the NUPOC video study guide number 86. Let's take a look at another chemistry problem here. Here we're asked to combine 4 liters of a solution having a pH of 4 with 6 liters of a solution having a pH of 6 and to find the pH of the resulting solution. So like we discussed I think a couple videos ago, we defined pH as the negative log of the molar concentration of hydrogen ions, but it's a little bit more meaningful to define it as the negative log of the molar concentration of hydronium ions, because in reality these hydrogen ions are just going to go and combine with a water molecule and we're going to get this H3O+. So I'll say that this one, both will give you the same pH and the same number, but I would say this one, or this definition, is more correct in a physical sense or a practical sense. Right, okay. So if we have 4 liters of a solution having a pH of 4, right, that means we have, if the pH equals 4, that means 4 equals, right, the negative log of this H3O+ molar concentration, which is the same thing as saying it equals the log of 1 over the H3O+ molar concentration. So when we raise each to the power of 10, right, because we can say 10 to the 4th equals, right, 10 to the log of 1 over H3O+, and then we can say this just equals 1 over H3O+, right, we find that the molar concentration of H3O+ equals 1 over 10 to the 4, or 10 to the minus 4 excuse me, moles per liter, right? Okay, so if we have 4 liters of it, that means in total we have 4 times that, so 4 times 10 to the minus 4 moles of H3O+ in that first solution. Now if I take this same method and I just replace all the 4's, right, with 6's essentially, because we have 6 liters of a pH of 6 solution, and I apply that same method I just did, we're going to find that we have, I'll write this, I'll say this is 4 times 10 to the minus 4 moles of H3O+ from the 4 liter solution. And if we do that same analysis, we find, right, that we have 6 times 10 to the minus 6 moles H3O+ from the 6 liter solution. Okay, and in total then we have 4 times 10 to the minus 4th plus 6 times 10 to the minus 6. This is like 2 orders of magnitude smaller than this, right? So I'm just going to say the total is approximately just 4 times 10 to the minus 4th. Because this is kind of like saying, what's 100 plus 1? It's about 100, you know. It's a 2 order of magnitude difference. So we're just going to essentially neglect the contribution from the pH 6 solution, the 6 liters of it. Okay. And that makes it easier just to do without a calculator, not worry too much about getting things exact. It's pretty darn close. Alright, so now we have this many moles of H3O plus, and we know that we have total 10 liters of solution, right? So the molar concentration is, let's see, point is 4, let's draw it over here, 4 times 10 to the minus 4th over 10 moles per liter. Okay, well, I'm just dividing this 4 times 10 to the minus 4th by 10, so I'm just making it 10 times smaller. So that's just the same as saying 4 times 10 to the minus 5th moles per liter. I'll just write that as I'll just write it out, per liter, right? And now I can just go ahead and say the new pH equals, right, the negative, well, I'll just say this, log of 1 over 4 times 10 to the minus 5th, which is the same thing as saying negative log 10 of 4 times 10 to the minus 5, right? And when we do that out, we get 4.4, right? And this, by the way, is 4 times 10 to the minus 5th, or I guess I should say 1 over 4 times 10 to the minus 5th. This is, this right here, this is like, I think it's something like 25,000 or something. So it's taking like log base 10 of 25,000, and we get 4.4. So I'll just write it right here just to box in the answer. New pH equals 4.4. Okay, so thanks for watching, and of course don't forget to subscribe. You can click this button right here so you make sure you don't miss out on any of the upcoming videos and study tips.